So today's lab is going to be a 2-day lab. We're going to start it off, it's called Study Assignment B, and it's about writing Lewis structures. We're doing that for both Thursday's lab and Tuesday's lab. Now, when you turn in your Study Assignment B, it's going to be a little bit different than usual. It's not going to be your entire part. Instead, what I'm going to be looking for, there we go, is these pages here. So starting from your exercises. Now I don't want just this table, right, front and back. I also want the questions. So as you go through, there are a lot of questions that you want to answer as you work through and draw your Lewis structures. And so we want to make sure we include all of those. Right? So it's a total of 1, 2, 3, 4, 5 pages. Okay. Now, we're going to walk through how we do some of these completions so that way we can clarify what should go into each of those boxes. And then today, I'm just going to focus on what things we should try to do for this beginning part of our study assignment. There's going to be an opportunity to come back and add to it. And on Tuesday, when we talk a little bit more about resonance structures and formal charges, we can add those to it. I just don't want to overwhelm you too much to begin with. Lewis structures are a lot about practice, practice, practice. And they can be very complicated to get them completely right the first time. So you want to make sure that you have some scratch paper or use this in pencil so that way you can make adjustments as you go through. Because you will have to take some, remake them, redraw them as you get better at all of those exceptions and rules to it. Now, the first thing that we're going to do is we're going to give an example for our CF4. So this is our section from Study Assignment B. And so what we're going to do is, let me move this down. Is in this first box, we want to fill in our number of valence electrons. So if we were looking at something like CF4, we would want to put our 4 valence electrons for our carbon. Plus, we have 4 fluorines, and each one has 7 valence electrons. And we want to add up all of those. So that 4 plus 4 plus 7 gives us a total of 28, 32 valence electrons. And that's what we would put in there. Now the bond skeleton is our first part where we choose our central atom, we put down each of the other atoms around it, and we connect them with just a single bond. So we put a carbon here, we put a fluorine, 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 we have 4 of them, 4, and then we connect them with our single covalent bond. And so that's what we need for our bond skeleton. For the remaining electrons, I'm going to make this a little bit bigger. We start off with 32 valence electrons. It's a little smaller. We've used 2, 4, 6, 8 in our single bonds. And so we should have a total of 24 valence electrons left over for our remaining. And so our Lewis structure ends up looking something like this. We have a carbon, fluorine, 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 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2. Now, I've used up 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 valence electrons. So I used up all of my valence electrons. All of my carbons, or sorry, all of my atoms have a full octet. I can check my central atom. It also has a full octet, 2, 4, 6, 8. And so this is my Lewis structure. Now we do want to include what we say is our formal charge. Now, formal charges is a little bit more complicated. And so for right now, I wouldn't worry about formal charges. We're going to come back to that on Tuesday. But when we would finally turn this in, then once we know our formal charges, we would go back and we would redo this part. It also is talking about resonance structures, which we'll also talk about on Tuesday. And so we can come back and we can talk about resonance structure. It basically means that you have more than one way to draw this one. And so they would have to be comparable. And so if you don't think there's a resonance structure, you could write no. If you did, then you would write yes, and you would write how many. So if we did think there was one, then we could write yes, and we could say 4. But it just depends on what we think is going on. So resonance structures, as well as formal charges, is not something that you have to start with. It's something that we should go back to once you've done a few of these. Right? So get a few of them under your belt. We can go back and we can work on them. What I will say, though, is formal charges will change which one should be our best answer. And so don't do this one in pen. Complete it in pencil. So that way, if you make a mistake, you can come back and you can erase and you can redo it. If you do it all in pen, then it's going to be a challenge. We're going to try one more. Let's look at this OCl2. So OCl2 is 6 from our oxygen plus 2 chlorines with 7 each. That gives us a total of 20 valence electrons. Our oxygen should go in the middle because it's in the lower group number. We should have our chlorine and our chlorine. From there, we can have our number of remaining electrons be updated. We've used up 4 of them. So instead of 20, we should have 16. Oxygen, chlorine, chlorine. We start on the chlorines. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we've used up 12 of those valence electrons. So we got 4 more left over. Our central oxygen needs 4 more. And now we can check. We have 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. And so that's going to be our Lewis structure. And so you can keep going through and you can complete all of those. If you get to a point where you have too many valence electrons, you have everything single bonded and you still have valence electrons left over, and that means that you have one of those exceptions to the octet rule. It means that you might have an expanded octet. And so we'll be looking at that. It also means that if you are going through and you're really struggling to complete something, you might have something what we call an odd numbered octet. So if your valence electron, your total count here, if it's odd, you're never going to be able to complete the octet rule for all of your atoms because you have an odd number. What I would recommend is double check that you're taking into account your charge correctly. And then if you still have an odd number, then that is something that we're going to talk about how to take care of on Tuesday. And so that should be enough for you guys to get started on your study assignment B. Now, your lab does start with a pretty good explanation of each of these different steps. So if you get stuck, you can work along that. I'm also linking a simulation where it kind of walks you guys through drawing Lewis structures through the module as well. So you have that there as well.